Hi everyone, this is Vipin Kumar here. Welcome back to my YouTube channel Vipin K Tech Tips, and in this video I am going to solve numerical problems from GATE Aerospace 2016 for flight mechanics subject. And this video is going to be very useful for the students who are preparing for GATE Aerospace 2021, and also equally useful for the students who are in third and fourth year of BTech Aerospace. So let's start with this. So here you can see I have collected numerical problems from GATE Aerospace 2016 for the flight mechanics. So question number 21, 22, 25, 32, 49, question number 50, 51, and 52 and 50. So let us start with question number 21. So as you can see, the damping ratio in a phagoid motion for gliders is usually less compared to powered aircraft because four options are given. Gliders are unpowered, this is correct. Gliders are light, this is also correct. Lift to drag ratio is higher for gliders, this is also correct. Gliders fly at low speed. All four options are correct, but which option is correct in the context of the question asked here? So for phagoid motion, if we talk about the damping ratio, so damping ratio is given by the formula 1 by under root 2 CD naught upon CL naught. So from this I can say damping ratio is directly proportional to CD by CL, or is 1 upon CL by CD. Okay. So from here, out of these four options, I can easily relate that damping ratio is inversely proportional to L by D ratio. Okay, so that means if L by D ratio is higher, then damping ratio is going to be lower, and we know that CL by CD is higher for gliders, so that is why option C is the correct option for question number 21. Now question number 22. During the aircraft cruising flight, the altitude above the ground is usually measured using four options. A is dynamic pressure, B is static pressure, C radar, D laser range finder. Okay, so all of us know that altitude of an aircraft is measured by an instrument called altimeter. Okay, and it works on the principle of static pressure. That is why option B is the correct answer here. Then question number 25. The load factor of an aircraft turning at a constant altitude is 2. The coefficient of lift required for turning flight as compared to the level flight at the same speed will be. So load factor 2 means lift is equal to twice of weight. Okay, this is for turning flight, and what is lift is equal to weight for level flight. Okay, that we know. Okay, so from here the coefficient of lift required for turning flight as compared to this, so let's say I denote this with LT, this with LL for level. So if I take the ratio of equation 1 and 2, so you can see here LT by LL is 2, or CLT, CL for turning flight by CL for level flight is also 2. So answer is the double. The coefficient of lift required for turning flight as compared to level flight at the same speed will be double. So answer C is correct here. Now question number 32. So question number 32 is basically from it is a common topic of aerodynamics and flight mechanics. So an untwisted wing of elliptical platform and aspect ratio 6 consists of thin symmetric airfoil sections. The coefficient of lift CL at 10° angle of attack assuming inviscid compressible flow is. So we have to find out CL. Okay, so from here first we will be finding out what is CL, means CL for the symmetric airfoil, and then we will be able to find out CL for the wing, untwisted wing. Okay, So if I look at the thin airfoil theory, so it says thin according to thin airfoil theory. Okay, so we know that Cl alpha is 2 pi and Cl alpha is also denoted by A naught, and the relation between A naught and A, where Cl alpha for wing is denoted by A. So the relation between these two parameters is given by this formula, A naught upon 1 plus A naught upon pi EAR. Okay, so A naught is 2 pi upon 1 plus 2 pi upon pi, and since it is a elliptical platform plane form, so E is equal to 1 and aspect ratio is 6. Okay, so you can see here 2 pi is 3, so 2 pi upon 1 plus 1 by 3 is 4 by 3, and it will be 3 by 3 pi by 2. Okay, so A is 3 pi by 2. Now this is A, this is Cl alpha. Okay, so this is Cl alpha. Cl alpha is 3 pi by 2. So what will be the value of Cl? Cl is Cl alpha into alpha, and alpha is given as 10 degree. So 3 pi by 2 multiplied with 10 degree. So this is in radians. So we have to uh, this is in per radian. So if I want to find out Cl, so I have to convert this degree 10 degree into radians. Okay, so that I can get a non-dimensional number here. So 10 into pi upon 1 pi by 180. Okay, so this is uh, pi by 180. So this is going to be 2 5 the 10, then 360 here. So 5 pi square by 60, or pi square by 12 is the answer. So Cl for the wing as per the given conditions is pi square by 12, and if we look at the options, so option B is correct here. Next is question number 49. So in question number 49, an aircraft is flying in the north direction at a velocity of 55 meter per second under crosswind from the east or east to west. For a given aircraft, Cn beta is 0.012 and Cn delta R is this. So we have to find out the delta R here. So let us write the given data here first. So given data is uh, V infinity is 55 meter per second, and small v, which is the crosswind, so that is 5 meter per second. Okay, and Cn beta is 0.012 per degree, and Cn delta R is Cn delta R is minus 0.0072 per degree. Okay, so here we have to find out the rudder deflection. Okay, rudder deflection delta R. So if we know that Cn beta into beta is equal to minus Cn delta R into delta R. Okay, so from this formula, if I write Cn beta into beta divided by Cn delta R and minus. Okay, so here in this question, beta is not known to us. So first we have to find out the beta. So if I draw the diagram, let's say this is an aircraft, this is an aircraft, uh, and because of crosswind it is flying at this 55 meter per second. Okay, this angle is beta, so 55 meter per second, and there is a crosswind of 5 meter per second means it is in negative direction. As per sign convention, if the velocity or the side force in is in this direction from this side to this side, that is considered negative. So this is negative here, so sine beta is minus this. So the value of beta from here is minus 5.216. So beta is minus 5.216 degree. Okay, this is the side slip angle. Now I can put the values here, and c and beta is given as 0.012, which is multiplied with minus 5.216 divided by 0.00712. Okay, and this minus sign is there in the formula, so this minus minus cancelled, so again one minus will be there. So when I calculated, so the radar deflection in degrees is 8.69. Okay, 8.69. So this is the answer for the radar deflection required, delta r required to balance the c and beta and crosswind effects. Okay, so this is 8.69. So from here this numerical and from theory also, you will see that beta and delta r both are opposite to each other in magnitude. If beta is positive, this will be negative, and if beta is negative, this will be positive. So that you have to remember. So the answer here is 8.69 degrees. Okay, now next question, question number 49, sorry, question number 50. An aircraft weighing 10,000 Newton is flying at level or flying level at 100 meters per second, and it powered by a jet engine. Thrust required for level flight is this. So TR is 1000 Newton, weight which is equal to L is 10,000 Newton, weight is equal to lift because it is a level flight. The maximum possible thrust produced by the jet engine is 5000 newtons. So thrust available, this is thrust available, which is 5000 newtons. The minimum time required to climb 1000 meters, so h is given as 1000 meters, and the flight speed is 100 meter per second. So v is 100 meter per second. So we have to find out the minimum time required. So we know that rate of climb is given by this formula. R is equal to TA minus TR V infinity by W, whereas TA minus TR is excess thrust. Thrust available minus thrust required is called as excess thrust multiplied with V infinity divided by W. So this gives us the rate of climb, and a rate of climb from here if I calculate. So TA is 5000, TR is 1000, V is 100, W is 10,000. Okay, so it will be 4000 divided by 100, so 40 meter per second. Okay, so this is the rate of climb. The vertical velocity also we can call it. So rate of climb is basically the vertical velocity. Now total distance to climb is 1000 meters. So that means if I take um, vertical height is 1000 meters, and when I divide it with the rate of climb, I will get time. Okay, so 1000 by 40 meter per second, that means 25 seconds. Okay, so 25 second is the time required here, so this is the answer. Next is question number 51. So question number 51 says that the aircraft velocity components in body axis are given by UVW. All three components of velocity are given. The velocity, air velocity meter per second, angle of attack degree, and side slip angle in that order are. So here we have to find out velocity, then alpha and beta. Okay, so V, alpha and beta, these three parameters we have to find out and we have to get the correct answer. So first is velocity. So three component of velocity are given, so what will be the resultant velocity? So that will be given by this formula. So it is from vector algebra. So if I put the values here, 100 square, 10 square plus 10 square, so that gives me around 100.995 meter per second. So this is the resultant velocity. So first is we have to see C and D are matching options for velocity. Now we have to find out alpha and beta. Okay, so this is the resultant velocity. Now we need to find out alpha first. So alpha is given by let's say alpha is given by sine inverse WR upon UR. WR upon UR. Okay, so what is WR? WR is 10, uh, sine inverse 10 by 100. U is the velocity 100, so that will give me alpha is 5.71. Okay, so 5.71 I have to check and which answer I'm getting. So here you can see in option D I'm getting this also and this also, so I don't need to calculate this. Okay, that means with these two answers only I can get the correct answer, so correct answer is D. But I should know how to calculate beta. So beta is basically is given by the formula of sine inverse VR, which is the crosswind velocity along the span-wise axis. So VR divided by resultant velocity V. So resultant velocity is this. So I will get sine inverse 10 upon 100 into 995. So answer is 5.68. Okay, this is the value of beta, which is correct. So option D is correct answer. Then question number 52. The Dutch roll motion of the aircraft is described by the following relationship. So Dutch roll motion is generally like this. This is the initial position. So aircraft perform this kind of motion. It is rolling, but it is coming back to its initial position. Okay, first it is rolling and changing its position in this direction, then in this direction, then in this. So this is called Dutch roll. Okay, so this is the equation given to us and we have to find out the undamped natural frequency and damping ratio for the Dutch roll motion in that order. So for that we have this matrix. So first we have to find out the root, which is basically the natural frequency. To find out the root of any problem, we have to take the characteristic equation of that. So I'll take the determinant of this in this manner, minus 0.26 minus lambda minus 1, 4.49 and 0.76 minus lambda, like this. Okay, so this will give me the characteristic equation. So characteristic equation will be just cross multiplication of this. Lambda square plus 1.02 lambda plus 4.6876. So this is the equation. This is the characteristic equation using which I can find out the value of omega. If I compare this equation with the equation of damped oscillation, so it is something like this: delta is lambda square plus 2 zeta omega n lambda plus omega n square. Okay, so if I compare with this equation, so from here I can say that omega n square is 4.6876. Okay, so I'll get omega as 2.165, whereas damping ratio, where this is damping ratio, so 2 zeta omega n is what? That is 1.02. Okay, so omega n is 2.165, so I can easily get zeta also. So zeta is 1.02 divided by twice of 2.165. So that gives the value of 0.235. So that is the damping ratio. So damping ratio of a Dutch roll is 0.235, and the natural frequency is 2.165. So if I check the options here, so option C is correct one. Okay, next is question number 53. So in question number 53, a glider weighing 3300 newtons is flying at 1000 meter above sea level. So this is 1000 meters. Glider position is somewhere here. The wing area is 14.1 square and the air density is 1.23 kg per meter cube. Under zero wind conditions, zero wind conditions means there is no disturbance, additional disturbance is not there. The velocity for maximum range. So we know that let's say this is the position of the aircraft and this is called range. Okay, so R max is obtained when CL by CD is maximum. Okay, and it is obtained, the CL by CD is maximum at some particular angle. So let's say this is the position of aircraft here. So it is approaching towards ground. So its gliding angle is theta, which is here also. Okay, so this table is given to us, and in this table if I look at the CL by CD ratios, so I have to find out the maximum value of CL by CD ratio. So here you can see that this is the maximum value, 25.7 is the maximum value, and the corresponding alpha for that is 3 degree. So CL by CD maximum is 25.7. Okay, and I know that the equation of motion for gliding flight is L is equal to W cos theta and D is equal to W sin theta. Okay, if I divide these two equations, so I'll get L by D as cot theta. Okay, or theta is equal to cot inverse L by D. Okay, so this will be giving me the gliding angle. Okay, so cot inverse 25.7 gives me the value of 2.23 degree of the angle here. Okay, now if I again put back this value of 2.23 in one of these two equations, so I'll be easily getting the value of the velocity. Okay, so let's say I put in this. So lift, what is the weight? Weight is 3300. So lift is equal to W cos theta. 3300 cos 2.23, where, okay, so L is equal to 3300 into cos 2.23 is equal to half rho v square S into CL. So we'll put the values given. So this is the equation, and we need to find out what is the velocity required for this particular condition. Okay, so half into density is 1.23. We have to find out the value of velocity. Surface area is 14.1. CL value is zero point 0.9 for 25.7 CL by CD. So this is the value of CL. So zero point 0.9. Okay. So if I solve this equation for V, first for V square and then for V, so the answer which I get is 20.6 meter per second. Okay, so 20.6 meter per second is the velocity required for the maximum range. Okay, this was the last question of GATE 2016 flight mechanics questions. Okay, so with this I'll stop my video, and yes friends, I have already uploaded 2017 and 2015 solution for flight mechanics problems, so you can check those videos also. Okay, so I'll be coming with the numerical solutions, will come coming with the question solutions from all GATE Aerospace years, starting from 2007 to 2020. Okay, so if you are preparing for GATE, so stay tuned on this channel. You'll get all the solutions. Thank you, all of you. Take care.